Good morning, student. The subject is linear circuit theory, a very important subject for the electrical and electronics student, and it is the base for analog circuits. Okay, 10 to 15% question of any competitive exam related to the gate, a ES, or any PSU comes from the linear circuit theory. I will assure you after completing this 20 or 25 lecture you can solve any question that comes into the gate exam, PSU or any other exam. Okay, so now first lecture, that is the property of electrical element and voltage current relation. So basic property of electrical element are linear, non-linear element, active or passive element, or unilateral or bilateral element. So first we discuss about the property of electrical element. After completing the property, we will make a relation between voltage and current of resistance, inductance and capacitance. If we know about the basic voltage current relation, we can solve easily any circuit problem. And after completing the voltage current relation, we discuss some basic numerical based on voltage and current. So basic property of electrical element is first is linear and non-linear element. So linear element, as we have heard about, the linear element are those elements which follow the rules of superposition. But if a equation input output relation is governed by, suppose by t equal to function of xt, where xt is the input and by t is the output. If output and input, if the proportionality ratio between these two quantity remain constant, then we say that element is linear, otherwise non-linear element. We are solving this by using some example, that the first example is by t equal to 2xt. We want to check this relation is linear or non-linear. So suppose we have taken the input value xt is 1, output value is 2. If xt value is 2, then output value become 4. If xt value is 3, then output value becomes 6. So the proportionality between input and output here is 2. Here is again 2. So this relation by t equal to 2xt is an linear relation. And the element which is governed by this equation is also the linear element. See, second is very important example. If we add a constant term into the equation, now equation become by t equal to 2xt plus 3. Now if we take the value of xt is 1, then by t value become 2 into 1, 2 plus 3, that is 5. If xt value is 2, then the value of by is 2 2 is 4 plus 3 7. If xt equal to 3, so by t become 3 2 is 6 plus 3 9. So input and output relation here does not govern by a constant. So this equation is an nonlinear equation. Okay, and the element is governed by this equation is also the nonlinear element. Always remember, by t equal to 2xt, if we add a constant term into the equation, by t, suppose we have equation by t equal to kxt, and we have add some term here, that is 3, then the equation become non-linear. Now, in case of third case, by t equal to 2x square t, if xt value is 1, then output by t is 1. If xt is 2, then by t, for xt is 1, output by t is 2, and for xt2 output is 8. For input 3, this is 3, 3 is 9 plus into 2, 18. So this again, the by t and xt relation is again not constant. So this is a non-linear equation. So basic relation, always remember, if by t equal to kxt, where k is a constant, is only the linear relation. If we add some constant term or making any power of x, then the equation become non-linear equation. Okay, so this is the what is linear and non-linear element. So basic element are resistance. Resistance is linear or non-linear. So basic equation of resistance is Bt equal to Rit. B is the voltage at x-axis. So this is the current in y-axis. So this is by t equal to kxt. So this is a linear element. In case of capacitor, basic capacitor equation, it always stores the charge whenever potential difference is applied across it. So qt equal to cvt, this is linear equation. So if we draw the plot between for the capacitor at x-axis, this is the bt, and at y-axis, that is the charge qt. Okay, so now capacitor is again a linear element. And third one is the inductor. Inductor, that is the symbol. So basic equation for the inductor is, inductor, there will always the flux across the inductor whenever pass a current across it. So phi t equal to Lit. Phi t is the flux across the inductor and it is representing the current across it. And when we draw the plot between phi t and it, so that is at x-axis, there is the current it, while phi t flux at the y-axis, that is again a linear relation. Okay, so resistance, induction and capacitance all are the linear element, while all electronics element, MOS, transistor, diode are the non-linear element. So see here, suppose a equation is given by Bt equal to 2it plus 3, is a linear relationship or not? So this is not an linear relationship because there is a term of plus 3. So this is a non-linear relationship. So next element is unilateral and bilateral element. Unilateral and bilateral element. All electrical element R, L and C are the bilateral element. What is the sense of bilateral? Bilateral means the characteristics of element is same in both the direction. So basic definition of bilateral element is, if we change the polarity of voltage source across the element, then the characteristics of element does not change. So see here, we have shown a curve. So in case of resistance, if we are applying the voltage B across the resistance, there is the flow of current I. And if we change the polarity of voltage B2 minus B, and the current become minus of I, but the characteristics, so characteristic remains same as in forward direction as well as in reverse direction. So resistance is an bilateral element. And if we talk about the charge capacitor, a charge across the capacitor, equation is qt equal to cvt. Okay, so if we apply the positive charge Bt across the capacitor voltage, then capacitor is charged with positive value of Qt, and if we change the voltage as minus Bt, then charge become minus Qt. So capacitor is also the bilateral element. Same with the case of inductor phi t equal to Lit. So x-axis variable is my current It and y-axis variable is the voltage. If we change It to as minus It, then the flux become plus phi to minus phi t. So all RLC, all electrical element are the bilateral element, have the characteristics same in both the direction, forward direction as well as in reverse direction, while all electronics element, that is diode, transistor, MOSFET, all are the unilateral element because they have different characteristics in the forward direction as well as in the reverse direction. Next is the active and passive element. So passive, first resistance, inductance and capacitance all are the passive element. Why these are the passive element? And what is the definition of passive? Passive elements means response or output across the element can't be greater than the excitation. Then the element is the passive. While in case of active element, response or output across the element can be greater than the excitation. So whenever we talk about the electronics element, in case of transistor, MOSFET, we talk about the voltage gain, current gain with respect to the signal. But we cannot charge a capacitor. We cannot charge a capacitor more than the applied voltage. If we are applying a 10 volt across the capacitor, capacitor is maximum charge value up to the 10. It will not charge more than 10 volt, even 10.0001. So all RLC element, electrical element, are the passive element, while all electronics elements are the active element. Next is very important. Here we will discuss about this voltage and current relationship in RLC, resistance, inductance and capacitance. So resistance, we have started the resistance from the 6th class onward, and it is remain throughout the 12th or up to the BTech level. So resistance, basic relation between voltage and current, Vt and It. So if you are applying the value of current It, so it flow from higher potential to the lower potential. Sign convention is plus and minus. So Vt equal to Rit. So this is the relationship. If you change the direction, if we take this direction here from negative to positive, always remember, then Bt become minus of Rit. When we take Bt equal to Rit, when current is representing from plus sign to the minus sign. Okay, current is always flow from higher potential to the lower potential. So whenever you showing the sign plus to minus, Bt is represented as Rit. If you change the direction, or if the current enter from the minus terminal, then Bt become equal to minus of Rit. So always remember this principle. So if current is given, multiplied with the resistance, we can get the voltage. And if voltage Bt is given, then current It become equal to the Bt upon R. So behavior of resistance remains same for DC as well as for the AC. So when we are applying, if we applying the AC voltage, so just current is equal to the divide the voltage by resistance R, but the waveform of voltage and current remains same in shape wise or phase wise, or voltage and current are in same phase. So next is very important from here, and it will create the difference. Okay, the basic voltage and current relation across the capacitor and across the inductor. So see, this is my capacitor. Symbol is, that is the symbol. So IT, that is plus minus BT, is representing the voltage. So always remember, when the current is entering, take that the plus sign, and this is the, and leaving sign as the minus sign. So basic equation is, first Qt equal to CVT, charge is equivalent to the capacitance into the voltage applied, BT. So current IT, rate flow of charge, so del Qt by del T. So IT current become equal to C del VT by del T. So if voltage BT is given, suppose we have given a voltage waveform, and say find the value of current IT, how can we find? First, differentiate the voltage, okay, or equation, multiplied with the C, capacitor magnitude, it will give you the value of current IT. Okay, so whenever voltage is given, differentiate the voltage, multiplied with C, get the voltage IT. And if the current is given, this is my current IT. Okay, if current is given and you have to find the voltage value, integrate the value of IT, okay, and multiplied it with 1 by C, that will give you the voltage BT. So BT equal to 1 upon C integration of IT dt, and in differential form IT equal to C del VT over del T. So these both equations are very important. Okay, some basic question in ES gate or any PSU will related to these two equations. Okay, so it is very important to learn about what is the basic relation across the capacitor. Now we are seeing the behavior of capacitor for DC supply. So here we have shown a figure, that is my capacitor C. This is my capacitor C, and we are applying a voltage VT across this, and suppose switch is closed at T equal to 0. This is representing that switch is closed at T equal to 0. Okay, so there are two conditions. First is, here we represent as the SC. SC representing the switching condition. Switching condition means when we are changing the condition of our circuit. So here switching, we are moving this switch from off to on condition. That is also switching condition if we are moving the switch from on to off condition. Switching means we are changing the circuit condition. Okay, so now in this condition, the switch is closed at T equal to 0. So for DC is always remain constant, but it will take some minimum time. It will take some minimum time from 0 to its maximum value. This time, this duration, switching time is very limited, or in nanosecond or picosecond. It is very minimum. Okay, and the slope of this equation is approximately 90 degree. This slope is approximately 90 degree. Okay, so but what is the behavior? So in switching condition, first we talk about the switching condition. So change in voltage del VT. So voltage change from 0 to maximum with taking very little time in nanosecond or picosecond. So my del VT by del T is very high. So change in del VT by del T is very high. So current, if we talk about the current IT, so IT is C del VT by del T. So when del VT by del T is very high, so this current is IT is very high, and very high current means that work as the short circuit. Okay, so important. Capacitor work as the short circuit in switching condition. Okay, capacitor work as short circuit in switching condition. In steady state condition, if we talk about the steady state condition, del V T by del T, there is no change in the voltage. So change in voltage with respect to the time becomes zero. So del V by del T becomes zero. So value of current IT is zero. So current zero means open circuit. So in steady state circuit or condition, capacitor work as the open circuit. Okay. A very important point about the capacitor, remember always, this is very important. Okay, capacitor voltage does not change instantaneously. What is the meaning of this? If we are changing the switching condition, or we are moving the switch from one condition to the another condition, then capacitor voltage remain constant in switching condition. So here we have shown the switch is moved at t equal to 0. So assume is BC0 minus is equal to the BC0 plus. BC0 minus 1 is representing the switching condition before switch is when the switch is open. BC0 plus is representing the condition when switch is closed. So in switching condition, we are assuming that BC0 minus is equal to the BC0 plus. Okay. Next is how the equivalent model of capacitor is represented. Capacitor model, equivalent model, is represented by the capacitor voltage C series with switching voltage, because we have changed the value at t equal to 0. So here we have represented as B0. If we have changed this condition at t equal to T1, we represent this voltage as BT1. So equivalent model of capacitor is always represented with the value of capacitance with initial voltage or switching voltage across this. Okay. So this is very important point about the capacitor. So capacitor work as the open circuit in steady state condition, while short circuit in open circuit in steady state condition, while short circuit in. So now here, next we are representing here for AC, behavior of the capacitor for the AC circuit. So basic relation that BCT equal to 1 upon C IT dt BCT. So if we take the Laplace of this equation, so this is the voltage BCS where S is representing the S J omega. So if we take the Laplace transform of this equation, so this is 1 upon C IS upon S plus minus into BC0 upon S. BC0 is representing the initial voltage across the capacitor, and this sign plus, there is plus sign or minus sign depend upon what the polarity of the voltage across the capacitor before t is less than 0. So capacitor voltage in frequency domain BCS become equal to 1 upon CS into IS with plus minus into BC0 by 0. If we assume initial condition is 0 or initial voltage across the capacitor is 0, so equation BCS become equal to 1 upon CS into IS. Okay, so in time domain C. So if we want to represent this equation in time domain, so BCS is BCT. So the magnitude IS current is multiplied with 1 upon CS. So magnitude is 1 upon mod of omega C. So here we are representing 1 upon omega C. And the phase 1 upon j omega So this will provide, this 1 upon cs provide a phase of 90 degree in denominator. So in numerator this phase become equal to minus of 90 degree. So value of voltage across the capacitor in time domain is equal to multiply the current I by a magnitude 1 upon omega c and take a phase difference of 90 degree. So clear indication, important point is this: the voltage across the capacitor is lagged by 90 degree of the current, or current across the capacitor is lead by 90 degree by the voltage of the capacitor. Okay, now we are discussing very important example. Let's see how the switching condition we find across the capacitor. So here we have shown a numerical example that there are the two switches. This switch is open at t equal to 0 and we are closing this switch at t equal to 0. Okay, so this voltage is V1 and this is the voltage V2 and that is the value of resistance R1 and C. Okay, so now what we have to find the value of I0. IT is representing the current across the capacitor. So we have to find the value of I0, BC0, okay, I infinity, I steady state and BC infinity. And BCT, this BCT is representing the voltage across the capacitor. Okay, so find the, we are changing the switch at t equal to 0. So we have to find the voltage and current across the capacitor at t equal to 0 in switching condition and voltage and current across the capacitor in steady state condition. Okay. So now see, we are starting. Before, for t is less than 0, for t is less than 0, voltage V1 is connect to the capacitor and V2 is open. And this condition is for a long time because switch is closed to V1 for a long time. So capacitor just work as the short circuit because in steady state condition, capacitor work as the uh, open circuit, sorry, capacitor work as the open circuit. So value of current I0 minus is 0 because in steady state condition capacitor work as the open circuit. So capacitor current is 0 because no current is flow across the capacitor. So when no current, so value of this voltage across this, so this voltage across the capacitor is equal to the applied voltage V1. So this voltage VC0 minus become equal to B1. Why we are representing 0 minus? Because this is the condition before the t is less than 0 and we are assuming this is a 0 minus condition. Important point is this. This is I0 minus and BC0 minus. This is not I0 and BC0. So important is we have said that the capacitor voltage does not change instantaneously. So here BC0 minus is equal to the BC0 and equal to the BC0 plus because capacitor voltage remain constant in switching condition. So this voltage is B1. So value of BC0 is B1. Now when we changing the switching condition and move the switch at t equal to 0, switch uh, the circuit is connected to B2 and B1 become open. So capacitor work as the short circuit in switching condition. So it is replaced by its voltage because capacitor in equivalent model of capacitor, we always represent the initial voltage. So capacitor value becomes short, but it is representing its initial voltage, that is V1. So value of current I0 across the capacitor become equal to the potential difference as V2 minus V1 upon total resistance, that is R1. So capacitor voltage BC0 in switching condition is V1, while the current I0 is V2 minus V1 upon R1. And in steady state condition, capacitor again work as the open circuit. So my current become 0 in the steady state condition, and the capacitor voltage PC infinity. Now capacitor is again charged to the applied voltage, and applied voltage is V2. So now capacitor voltage become equal to the V2. Okay. So value of BC0 minus BC0 plus is V1, and I0 is V2 minus V1 upon R1, and steady state current I infinity is 0 and BC infinity equal to V2. So see, now next element is inductor. Inductor is also a very important element. So voltage current relation, current is IT, symbol is L, and voltage VT is representing as VT. Okay, so voltage across the inductor relation is VT equal to L del I by del T. Voltage Vt equal to LdI by dt. So if current is given across the inductor, differentiate the current, multiply it with L, that will give you the voltage across the inductor. If you want to find the current across the inductor, if voltage is given, integrate the voltage Vt dt, multiply this 1 by L, that will give you the current across the inductor. So basic relation of Vt and It, Vt equal to LdI by dt, and current It equal to 1 upon L integration of Vt and dt. For DC supply, see here, for behavior of inductance, inductor for DC as well as for DC. So here we have shown an inductor, and here we have taken the current IT. Remember, when we are using the capacitor, we have taken the as the voltage, but here we are taking the current source. Why? Because basic equation of inductor is it always induce flux when there is always the current. So basic equation of inductor is phi t equal to Lit. So we have taken current source as the source, and suppose this switch is closed at t equal to 0. T equal to 0. So what is the condition in switching condition? In steady state condition, so current IT. So initially that is my switching condition, t equal to 0 to 0 plus, and after that we are representing the steady state condition. So between switching condition 0 to 0 plus, here again del I by del T, this is change in current is very high, slope representing the slope, again approximately equivalent to the 90 degree. So del I by del T is very high, and voltage Vt equal to LdI by dt. Therefore voltage Vt is very high, and high voltage signify as the open circuit. So in initial condition for the DC supply voltage, the inductor work as the open circuit, while in steady state condition, in case of steady state condition, now change in current become 0, del I by del T is 0. So voltage across the inductor is 0, and voltage 0 means short circuit. So in steady state condition, capacitor work as the short circuit. Very important. Okay. So in switching condition, capacitor work as the open circuit, while in steady state condition, inductor work as the open circuit, while in steady state condition, inductor work as the short circuit. Now, if we talk for the AC supply, if we take the Laplace transform of equation Vt equal to L del I by del T, so this is Bs. Del I by del T is replaced as Sis minus I0. Okay, if we take the initial value of current is 0 across the inductor, So voltage across the inductor Bs become equal to LSIs. Okay. So voltage is Bs equal to LSIs. Okay. Now in time domain, Bj omega equal to J omega L into Is. If we put the value of S as J omega, so voltage S equal to J omega, Bj omega is equal to J omega L into Is. Just wait. Now see. So in time domain, in frequency domain, Bs equal to uh, j omega L into Is. So in time domain Bt, current is multiplied by a term of omega into L, reactance of the inductor. Okay, and current It, because j omega L is always give the 90 degree. So current I is adding with the angle of plus 90 degree. So in case of inductor, important point is this: in case of inductor, voltage across the inductor lead by the current of the 90 degree. While in case of capacitor, voltage across the capacitor lag by the current of IT by the 90 degree. Okay, so that is a very important thing. Next important is when we always talk about a switching condition. So inductor current does not change instantaneously. Inductor current does not change instantaneously means IL0 minus equal to IL0 plus. So in case of capacitor voltage does not change instantaneously, or we assume that the capacitor voltage constant in switching condition and the inductor current is constant in switching condition. So whenever we draw the equivalent model of the inductor, we always represent initial current parallel to the inductor. So inductor parallelly represent as L parallel with a current source. Here again we are discussing one problem. Here same, here is the voltage V1 and V2 and the resistance value is R and L, and IT is representing the current, and suppose BL or BT is the voltage across the inductor. This is the voltage BLT. Okay, so find again the value of in switching condition I0, I infinity, BL0 and BL infinity. And what is the switching condition? The switch is moved from uh, this switch is off at t equal to 0, while this is closed at t equal to 0. Okay, so now I am just clearing my drawing and wait. Okay, but remember always in switching condition, capacitor voltage and inductor current does not change instantaneously. So before t is less than 0, B1 is close to my circuit. Okay, so see, so for t is less than 0, so B1 is connected to the circuit, B2 is an open circuit, and steady state condition, because this switch is closed for a long time. So in steady state condition, inductor work as the short circuit. So current IL0 minus is B1 by R, Why 0 minus? What is 0 minus signify? 0 minus is signifying just before switching. Okay, so just before switching, B1 is closed for a long time, so inductor is working as the short circuit. So value of current in this circuit is B1 by R. Okay, and this is IL0, and this is also IL0 plus, because but we have said that inductor current does not change instantaneously. So IL0 minus is equal to IL0 equal to the IL0 plus. So for the voltage at t equal to 0, but we have said at t equal to 0 this circuit is open. Okay, so this switch is closed. Okay, so inductor work as the open circuit, but always represented by the initial current across the inductor is B1 by R. That is IL0 minus is equal to IL0. So voltage, when we apply the KVL in this equation, so this is minus B2 plus value of resistance is R, and current in this equation resistance is B1 by R, and that voltage is BL0 equal to 0. So value of inductor voltage at T equal to 0 is B2 minus B1. Okay, and at t equal to infinity, if we see in steady state condition, now again inductor work as the short circuit. So V2 and divided by R, this will give my current. So IL infinity current is B2 by R, and inductor voltage BL infinity, because inductor is short circuit, so now current become 0. So inductor work as the short circuit, so voltage become 0. Okay, so these all my parameter. Now we are discussing some conceptual question. Okay, see, okay, just go through is which one have, first question is which one have more resistance, 1 kilowatt heater or 2 kilowatt heater. Okay, because there are the two relation, P equal to I square R, sorry, P equal to I square R and P equal to B square R. So first find which one have more resistance, 1 kilowatt and 2 kilowatt heater, and why. You have to find the answer of this question. Next is calculate the current in both the figure. Okay, suppose this is my 10 volt supply and this is my 5 volt supply. We have to find the value of this current. What is the value of this current I? And in second question, calculate this value of current I. If this current, just wait, if this current is 8 ampere, this current is 4 ampere, and this current is 3 ampere, then find the value of this current I. Okay, and calculate the value of current I in this case. We will discuss these two questions in the next lecture. Okay, just wait. So in coming lecture, uh, in this lecture, we have discussed about the property of electrical element, that is unilateral, bilateral and passive element. Okay, then we discussed about the voltage and current relationship and some question. And next question will be next lecture will be very important. In next lecture, we will discuss about these questions. Okay, you can give me this question by mail. You can respond this question to my mail ID or in comment section as given below, or uh, discuss in the, you can see the next lecture for the answer. Next, complete study of nodal analysis. Nodal analysis is very important to find the current and voltage in a circuit. So in next lecture, we will discuss about the nodal analysis. Second, what is the concept of supernode? We will also discuss about the supernode analysis. What is supernode? Supernode means when two node, when between the two node there is only the voltage source, no resistance. So how can we find the current? So that is, we will discuss about the supernode analysis. Next is concept of dependent source. What is dependent source? If we draw the analog circuit, okay, equivalent circuit of analog circuit, there will always be the different type of source. So if you know about the dependent source and how we calculate the input and output resistance, that will be very useful to solve the analog circuit and some basic numerical example into the next lecture. Thank you. Hope you like this lecture. Okay, for for the nodal analysis and supernodal analysis and concept of dependent source. These all terms we will discuss into the next lecture. Thank you.